Question 3 from the AAHL exam is here, which you'll see is very similar to question 4 from the AASL exam, with the only exception being part D, as you can see here, which is added on to the end. And so the following recording is my answer to question 4 from the AASL exam. And then after that, you'll have a recording of me running through the answer to part D. Question 4. A function f is defined by fx is equal to 2x minus 1 over x plus 1, where x is an element of real numbers and x cannot equal -1. Part A asks, the graph of y equals fx has a vertical asymptote and a horizontal asymptote. Write down the equation of part 1, the vertical asymptote, and part 2, the horizontal asymptote. Okay, so for the vertical asymptote, this will always be in the form of x equals a number. And you'll find quite often that this is given in the first line of the question, okay? Which here we're told we've got x cannot equal -1. Now, the reason why x can't equal -1 is if we were to put that x equals -1 into the denominator here, we would get 0. And we can't divide by 0 because then our function is undefined. Okay, so that is a bit of a hard and fast rule that you can take. So the vertical asymptote here is going to be x is equal to -1. We will copy this down and we'll do all the working. It's on the next page here, so we'll do it down there. Now, the horizontal asymptote for these functions, which they're called rational functions, and I'll give you their form as well. So the form of rational functions are ax plus b over cx plus d. All right, and so that's essentially what we have for f here. And we will write the horizontal asymptote as the limit as x tends to positive and negative infinity of fx. Now, I know that might not mean an awful lot yet, but I will explain that as we go down. All right, so let me get rid of this here. Let's come down. So I'll write a bit of a note in blue, so you wouldn't have to write the blue bit here in your exam, but the red bit that I write will be the kind of the answer. All right, the answer plus the working. All right, so for any rational function, fx is equal to, I think I just copied here, yeah, ax plus b, it's made a little small, ax plus b over cx plus d. Our vertical asymptote is x is equal to d over c. Sorry, negative d over c. Okay, and you'll see that this is essentially the value of x that makes the denominator equal to 0. And so equally, so for the horizontal asymptote, is y is equal to negative a, sorry, what am I doing? Not negative, just a over c. So effectively the coefficients of x divided by each other. So yeah, a over c. So if we were to write our answers in here, so first of all, we're asked to put in the vertical asymptote. So let's just write this. We'll go vertical asymptote is style red, right? X is equal to -1. And yeah, as I said earlier, quite often this is given to you in the first sentence of the question, of these types of question. So yeah, look out for that. And then now this idea here, okay, so the horizontal asymptote. So now you can just use this formula here and you'll see that it's 2 and 1. I do want to sort of illustrate this idea or expand on this idea of the limit as x tends to positive or negative infinity. So if we write that down here, limit as x tends to positive and negative infinity of, what do we have, 2x minus 1 over x plus 1, what we end up getting is 2 lots of plus and minus infinity minus 1 over plus or minus infinity plus 1. Okay, now the minus 1 on the top and the plus 1 on the bottom will, considering we're working with infinity here, will do very little to the value of this limit. Okay, so specifically all we're going to be looking at is the coefficients of x, or the coefficients of positive and negative infinity. And so what we're going to say is that this is equal to 2. Okay, because effectively this cancels out with this, right? And the -1 plus 1, they basically make no effect. All right, so then therefore what we're going to say, therefore the horizontal asymptote, I'm just going to copy this. Oh, what have I done? Brought the y over. Let's make that into red, is y is equal to 2. All right, and so there is the answer for part A. And this idea here for the limit, the reason why I wanted to expand on that idea is this is going to help quite a bit for this next part, so part B, okay, for when we get to sketching the graph. All right, so yeah, going up to part B, we are asked, on the set of axes below, sketch the graph of y equals fx. I'm just going to put equals to 2 here as well. So we got that. Okay, so how about so first of all, let's draw in the asymptotes we have, okay? And we'll do that with a dotted line. So here is, oh, that's not perfect, is it? But we'll line it up. And so that is the equation of the vertical asymptote there. Yeah, I don't think this photocopy was taken straight, but that's all right. Okay, cool. So we got that there. And then also the equation of the horizontal asymptote is going to be y is equal to 2. Right, and so there we have the 2 asymptotes drawn. Okay. Though for this question here, we're going to need, so we're saying on your sketch, clearly indicate the asymptotes. So we've got that here. The asymptotes, but equally, and the position of any points of intersection with the axes. We'll just get intersection with the axes. We'll also indicate there. All right. So let's go back down to our working page and we'll talk a little bit about the how to find the x-intercept and the y-intercept for these rational functions. So I'm going to copy this for any rational function idea here. Let's bring this down. So for any rational function, the x-intercept is going to be as follows, okay, is -b over a comma 0. And hold on, let's bring this over to here, make it a little smaller. And the y-intercept is going to be when x is equal to 0, and then b over d. Okay, and there you have it. And you can also, if you forget this, the x-intercept is when the function or y is equal to 0, so you can go through and just sort of solve that. Okay, and the y-intercept is when x is equal to 0. And then just expanding a little bit on the idea of the x-intercept when the function is equal to 0. When you're trying to find that, all you're concerned about is making the numerator equal to 0, because it doesn't matter what you divide 0 by, it's always 0. So yeah, 0 divided by anything is always going to be equal to 0. That's all we'd be concerned about there. Okay, cool. So then in terms of our question here, we got x. The x-intercept here is going to be not -0.5. It's going to be, what do we have? So yeah, -1/2, beg your pardon. Yeah. No, sorry, because we've already got -1, so it's -1. So yeah, just a half, comma 0, and the y-intercept is going to be equal to 0, comma, and then b over d, which is -1 over d, which was 1, which is just -1. All right, cool. So there we have our x-intercept and y-intercept. Let's mark that on a graph here. So we got our x-intercept here of 1/2, comma 0. Okay, and then equally the y-intercept, which was 0, comma -1. And I'm just going to zoom in a little bit here. Move this guy to there, and move this guy slightly over to there. Okay, cool. So there we have now the x-intercept, y-intercept, and also our asymptotes drawn. Let's just mark those. We'll say this is where y is equal to 2, and this is where x is equal to -1, for our vertical asymptote. Now, in our part B, we talked about the limits. Sorry, part two of question A. We talked about the limits as x tends to positive and negative infinity. All right, and we found that our function tends towards 2. Okay, so it goes towards this 2 idea. So as x tends towards positive infinity, our line tends towards this line y equals 2, but never quite touches it. Okay, so it never touches it, but it tends towards that value. Okay, equally, we know as x tends towards negative infinity, so going this way, our line is going to come down. It's going to tend towards this line here. That wasn't very good. Tend towards y is equal to 2, but it won't ever touch that line. Okay, so that gives us a little bit of an indication, or a bit of help as to the shape of our graph. And so we know on the positive side of x, okay, as x increases there, we want our line going towards the line of y equals 2, and equally on the other side, we want our line when it goes to, as x tends to negative infinity, we want our graph tending towards this line of y is equal to 2. All right, and so then when we think about that, this bottom bit is going to, so we've got to go through our y-intercept and x-intercept. And so we'll get a line somewhat similar to this here. Okay, and then as x increases, this line gets closer and closer to y is equal to 2, but never touches it. Equally, as y gets, as y tends towards negative infinity, or as x tends towards -1, all right, we know that our graph, our function tends towards negative infinity. Okay, and then now we go up to the top, and so we also know that on this negative side, okay, so around here, we need our graph tending towards y is equal to 2, but never quite touching it. All right, and so then we get this idea here, where we come through and we go out like this. All right, and then there we have our graph, okay, of fx, of y is equal to fx. And yeah, that should suffice for part B. Okay, let's move on. Part C asks, hence solve the inequality. 0 is less than 2x minus 1 over x plus 1, which is less than 2. Okay, so if we look at our graph here, we need to find when our function fx, because this here, this expression here, is just fx. So going up to our graph, we've got to find when is the value of fx between 0 and 2. Okay, and we can specifically see that that is from this point onwards here. Okay, yeah, so from the x-intercept onwards, all right? And we know that since we found the limit, that fx will never touch, it'll never get to y is equal to 2. So simply the answer, or the solving this inequality, is just x needs to be more than a half, right? And so we can write that down here and say for 0, and then we'll say, what's it, 2x plus 1. Oh, wait, it was minus 1, wasn't it? 2x minus 1 over x plus 1 less than 2. X must always be more than a half. And there is the answer to part C. Okay, on to part D. Solve the inequality. Here, this inequality here. And so we'll come down and I've copied it down here, and I've also brought our graph. And so it's quite easy to overthink this one here, because it probably looks more complicated than it really is. So what we're going to think is, if we have when x or for x is greater than 0, all right, our expression here, 2 multiplied by the x minus 1 over the absolute value of, don't want to go straight from here, x, not brackets, sorry, absolute value, plus 1. Now this is just going to equal effectively fx, which was 2x minus 1 over x plus 1. All right, and so that's pretty straightforward. Okay, so that's just going to be, so if I sort of redo our graph in purple for this function here, the absolute value stuff in it, that's just going to be identical for when x is greater than 0. So anything to the right of the y-axis. Okay, so now when we think of, now let's have a look at when x is negative. All right, so for x is less than 0. All right, so then this idea here, so 2 multiplied by x, the absolute value of x, minus 1 over x plus 1. Now, this is going to be effectively, so we're considering only negative values of x, okay? So, and what this absolute value sign is, makes these negative values positive, right? So what we could effectively do is just multiply it by -1. Okay, so we could just put a negative x into our function. And so then we can say that this is going to equal 2 multiplied by negative x minus 1 over negative x plus 1. So you can think about it like that, or equally, you can sort of have the idea of, well, if x is equal to -1/2, then we're going to have to just find the corresponding value for when x is 1/2, okay? Because that's what we're going to be effectively plugging into our function. And so if we zoom in onto our function here on our graph, well, when x is 1/2 here, y is equal to 0. All right, so that means when x is equal to -1/2 for our new function, y is also going to have to be 0. So we end up seeing that we effectively just get a, pardon my drawing, I know it's not perfect, I was never an artist, but you can see that we end up just getting a reflection in the y-axis here. All right, so that's effectively all we get. So, and you could also note that this thing here, this looks like f of -x, which means therefore reflect in y-axis. All right, you should probably remember that from your transformations section or idea. All right, and so then now we have a graph of the inequality here, and we can kind of tell, okay, well, when is this inequality between 0 and 2? Well, it's always going to be below 2 because we still have that horizontal asymptote of y is equal to 2. But we have sort of two parts now that are greater than 0. We have sort of, if I highlight in green, we've got this sort of section down to here, and then this section up here. All right, so to answer our question, this inequality is satisfied for x is greater than a half and x is less than negative a half. All right, and then that is the answer to part D.